Welcome, Fergus. Fergus is in the water science branch, and he's going to talk to us about applying the river styles framework to the river network in New South Wales. So are you good if we work with 15 or 20 minutes for presentation?
Yeah, that's fine. There's no problems at all.
And 10 for questions. So over to you.
Okay, everyone. My name's Fergus Hancock in Water Science Programs in Newcastle. I'm talking about a long-term project called River Styles that the department devised with our partners at Macquarie University, and it's to meet our obligations under the Water Management Act to understand and incorporate risks associated with geomorphic processes in our decision making. Now, in the cover pictures, I'm trying to pair river images using the same river. This is a good example of the degraded river in the Hunter Valley. The right-hand image is a rehabilitation reach, only about 3 or 4 kilometres away. So it has real implications for not only the physical state of the river, but also to do with issues such as water access and availability. And our partner organisations are adopting the River Styles framework, and in our database, which I'll talk about later, is really in demand right across the state. Okay, so geomorphology, for those who don't use it regularly, is a branch of physics. It has to do with the processes and forces that shape and create rivers, that maintain and rework them, but it can also destroy river features. And anyone who's been involved in an active flooding zone would certainly know how powerful flooding forces can be. But it provides insights for us to know how to go about the decision-making process, and in particular where we have rivers that have been affected and degraded because of human activity, what the options are, and how we can go about managing rivers to be of best benefit to everyone. I won't go through in detail, but river styles is a way of characterising rivers based on like classes or like feature sets. And as you can see in the diagram, that extends to floodplain features, including backwater swamps, which is probably related to that question to Dan, and also in channel features. And you'll see in that bottom diagram how complex river channels can be. In fact, most of the time when we look at fairly simple river channels, it's more because they've been impacted and altered from where they were pre-European disturbance. River styles are useful because the structure I've shown on the right-hand side shows that we start at catchment level, we can go down to reach level, and we go right down to individual hydraulic unit level, that is an individual pool, an individual rock bar or shoot or tree stump or log. By doing that, it allows us to categorise and classify rivers that can provide really useful information. And the three I've noted in that first dot point relate to the inherent fragility of a river, that is its ability and susceptibility to adjust into some other condition, the geomorphic condition, which we've mapped right across the state, and then the potential for recovery. Those images down the bottom are of the same river. Again, they're only a couple of kilometres apart. The left-hand image in the 60s is at a state where the river had simply been completely destroyed. There was no low flow channel, no pools, there was nothing left behind. In fact, the water sharing plan doesn't have a pool rule because at the time when it was devised, pools simply hadn't restructured and reshaped themselves. The right image taken in 2015 shows how the river is now rapidly recovering, and we're now getting permanent pools being reformed within the low flow channel. And those pools are deep enough, if you wanted to go for a swim, you definitely could. In New South Wales, we have identified well over 60 different river styles, and each particular style has its own feature set, that is, its own set of characterising features, and that guides and drives the behaviour of each particular river. Now that means we can then identify what will happen to access to those rivers if they undergo some level of adjustment. We can then prioritise them based on their risk of physical disturbance, which we have also done. In most cases, though, in New South Wales, on the larger rivers, we're dealing with rivers which have been affected since Europeans turned up. And unfortunately, as in the case in this photo on the Hunter River, attempts to fix the river often lead to even greater problems than were originally there. In this case, an attempt to armour the bank of the Hunter River to be led to massive degradation. By 1870, the river had more than doubled its width. The channel had infilled with a huge amount of sediment, and even now the state government or the Ports Corporation is spending tens of millions of dollars dredging what used to be riverbanks and floodplains out of the harbour to allow carriers and coal ships to enter into Newcastle. Some other consequences are ongoing. This photo is of the McIntyre River, the northern part of the state. You can see on the right-hand half of the image that there are intact pools, although it's not in the best condition. But on the downstream side, on the left-hand side of the image, the pools have more or less disappeared because a sediment slug is moving into the river from that bottom tributary, the Bannockburn Creek. Most of this slug has migrated in since 2002, and the slug is still continuing to migrate down through the river and posing an increased level of risk, particularly for those water users who want to use the McIntyre to access water. In this image, which is on the Bega River, I've identified that we're looking at causes which are not located at the site. You can see just how massive the level of adjustment and sediment infilling into the Bega River has been. But that sediment is not locally sourced. It's sourced from major channel degradation 20 to 50 kilometres upstream, which means that we need to have an entire perspective on processes happening throughout a catchment if we have a chance to be able to identify the risks and then deal with those risks in each particular catchment. In this case, it is going to take several decades to possibly a few centuries for the Bega to recover to anywhere near the state it was in prior to Europeans turning up. And yet, as usual, the first option people would tend to come up with is let's send in the dozers and dig out all the in-channel sediments, which would again trigger a huge wave of degradation and make the river channel even worse than it is at the moment. And lastly, just on consequence, and I've focused particularly on sediment, but it can also have major impacts on water infrastructure. This dam, the Junction Reefs dams on the Belubula River, and although it was created to supply water to the gold mines close to Orange, that was forced into abandonment by 1926 because huge degradation happening in the upstream parts of the Belubula River swamped the entire dam pool with sediment. They couldn't operate their weir gates, although they tried to use dynamite to open the gates up. And the dam was abandoned only about less than 30 years after the dam was originally opened. So it can have real impacts on major infrastructure, and you can imagine the impacts this would have on landholders attempting to use pumps on pools. It can have some really significant impacts on ecosystems and ecosystem recovery. And when we're looking at impacts, particularly in the Murray-Darling Basin, when we're looking at water management, well, we need to also look at the physical template, because quite often the reason that species may not be present or may be at risk is because of changes and damage to the physical structure of the river as much as it is to do with flow management. So, is it possible for these rivers to return? Again, these paired photos are of the same reach on Wollombi Brook in the Hunter River. The upstream photo, 1965, you could easily have walked through the river when there was this knee deep. The photo below, the same spot, 2007, the pools are reforming and we're round about a metre in depth. We've had 3 significant floods since then, and pool depths in that area are very nearly 2 metres deep. And we are now seeing permanent connection between those pools, allowing fish migration. And we're hoping we'll start seeing recovery in freshwater mussels and other species that were simply obliterated, were wiped out from this river. It's a fairly significant time frame, but most of the recovery in Wallumbilla Brooks occurred since 2000. So these rivers can bounce back, and bounce back quickly if management decisions are properly made. Right now, across New South Wales, we have an extensive database that was first set up in 2004 and is currently undergoing continual revision. It covers up to 220,000 kilometres of river reaches in every major catchment in the state. The dark green, if it comes out as dark green on your screen, is where catchments are being reviewed, so we can actually look at trend lines and say what is the trend in the physical state of these rivers, and are these rivers beginning to recover, or are we seeing continued degradation? The dot points on the right hand side indicate what kind of projects that physical geomorphic information feeds into. And I've identified 2 particular projects which I'm helping with or running, and they will expand and go right across New South Wales. One is to do with the mitigative effects on flooding as geomorphic recovery occurs, and the second, which I'll be working with John Sayers, is can we start to answer whether or not geomorphic recovery is going to have an impact or an effect on low flows and connectivity between pools in river systems. So if we're looking at priority and high risk rivers in the state, in this map, the green reaches are identified conservation reaches, that is, rivers that are in generally reasonable condition, and the highest priority is to conserve and protect their inherent form. The bluish coloured features are those where geomorphic recovery is occurring, and what we need to do is to understand the processes which are driving recovery and to basically work with nature to help recovery increase and let channel forms recover and bounce back to close to where they were. The darker areas, that's red on my map, it might be dark on yours, are those river reaches that are strategic, that is, river reaches that are in trouble, that are threatened by degradation of other geomorphic processes, or rivers that are causing a break, a division between higher condition reaches elsewhere upstream and downstream. And as you can see, there's a huge amount of river reaches which are in strategic state and will need to have specific management tools applied to them, particularly if these rivers have high extractive stress. Another example which we use is in our reporting to the Commonwealth. River Styles is an accredited reporting tool to the MDBA and to Commonwealth agencies, and it's also one that we partner with, in this case, with DPI Fisheries and with OEH. We also have partnerships drawn up with local land services in all areas of the state where LLS have catchment action plans or priority action plans at the moment. In this map in the Namoi, we identified where threatened species, in this case the greenish lighter colours are threatened frogs, and the dark colours are particularly silver perch, where they've been located or identified within the Namoi catchment. And you'll notice, particularly for the frogs, that there's a lot of clustering. In particular, the light green area in the northern Pilliga is identified as being particularly of high value for frog populations. And the reason for that is that it correlates with rare and threatened river styles, in this case, chain of ponds, when the largest cluster of intact chain of ponds in the state is located in the Northern Pilliga. Nearly all chain of ponds also are in the state of being destroyed or have adjusted into poor condition. But the Northern Pilliga and the Upper Wingecarribee and the Upper Hawkesbury catchment are the only large clusters of chain of ponds left. And you'll notice how closely the frog populations correlate to the two chain of ponds, whereas the Burrelong frog, which is in the dark blue, is scattered in a number of different other river styles elsewhere in the catchment. So it's really saying that we can get a fairly good handle, a predictive tool to say, if we have a particular river style and it's in a particular condition, then we can predict that it may well have different frog species, different fish species that may be acting as a stronghold where species may have been driven out elsewhere in the state. The one other note in this slide is the regulated Namoy River in the central part of the map is known for having silver perch, but it's a river style which is also under very significant threat because the Namoy River is undergoing significant geomorphic change. It's degrading. It has been identified by fisheries as having significant sedimentation issues behind all the regulated weirs, and it will be identified as having one of the highest priorities for remediation and particularly a focus on revegetation of the river red gum communities that have been located along them and at the moment are under threat of being lost. So for management decisions, we as an agency have some choices to make. At the moment, we're providing guidance to local land services. We're working with DPI fisheries on fish habitat, and we're working more closely with OEH on risk to do with habitat and ecosystem threats. These two images, again, the same river, are located in the Hunter Valley. The reach located on the left is a stronghold or a recovery reach, where the river had gone through one of the most significant floods in European record in 2015 with no adjustment. The reach on the right, 3 kilometres downstream, is going through dramatic adjustment, riverbank collapse, loss of vegetation. The very bench that I'm standing on has a large fraction, is about to collapse into the river system. So we as an agency can provide guidance to our partner agencies. We can use this to inform, and we are using to inform our reporting to the Commonwealth, and we need to continue to prioritise where rivers are under threat and where both their ecosystem values, water quality and usability for water users can be put in risk in future. So I want to thank you for your time and open up to any questions.
Hey, Fergus, it's Alan Rain speaking. Great presentation. I guess I wanted to reiterate the importance of having an understanding of geomorphology, particularly in the basin. There's a lot of work happening in the MER space in the basin to illustrate how flow management has increased fish populations or helped in recovery of particular fish species, but often geomorphology, which I call the forgotten science, is a major driver of these things. So in some cases, we can turn the tap on and add more water, but you won't see the recovery of particular taxa simply because the geomorphology is not in place to support those species.
I've got a question for you. Yeah, it's interesting to note, and we all know physical processes within the movement of water, and the regulation we have done is changed the geomorphology of the major river systems. The one particular you mentioned is Namoy River. Now, I've been involved with management decisions in running the river for the last many years since the Millennium Drought, and we haven't ran the river continuously. So there are holes, and ecology would be probably at risk and is already died because of many years the river has not been run. And that's the kind of management. So what do you think? What should change to make that happen? Because then if we run the river, then we we are unable to supply irrigator waters or other essential. And so what sort of management decisions are required in that time frame?
Okay, thank you very much for the question. In the past, most of the geomorphic issues have been addressed by conducting really major scale engineering works, trying to straighten and redirect rivers, trying to do major rock armouring of banks, things like that. We've realised that in a lot of cases that's not been a really effective use of money. That's far more important to enhance where we know geomorphic recovery is occurring, but where there are particular risks or active degradation occurring, it really is a matter of identifying the source and the particular causes, and then address those particular causes. Now, that's helped us to the documented reports on river styles across the state to, at the time of writing, the state, these are the particular risks, and this is why we're identifying these reaches may be strategic and may need intervention. In other cases, and say in the Namoy, you would be aware along Cox's Creek, it's a particularly high extractive stress river, but it has very, very low prospects of geomorphic recovery in the near future. So we said, look, we can't prioritise that river. We need to prioritise where we think geomorphic recovery is more likely to occur. See those systems are starting to return back, and then to address the poorer condition reaches. And then there's a whole suite of actions that can be undertaken. In most rivers across New South Wales, the simple action is to restrict cattle. And if cattle access is restricted and alternate water is supplied to cattle, we found that that the weed management then becomes the next major issue. That means they may need to target either weed eradication or even crash graze. But yeah, it means that every single river will have its own suite of management actions that need to be done to it. Okay, are there any other questions? Sorry.
Hi Fergus, I have a question. Have you found that in some of the rehabilitated stretches that there's been a change to groundwater recharge? Because I assume that there would be more if you're slowing the rivers down and increasing the number of pools and things like that.
Okay, what we found is that riverbed levels will tend to, as rivers are recovering, riverbed levels will tend to accrete. They'll tend to collect sediment, revegetate, and the bed levels will begin to rise. Once that occurs, then yeah, that will help drive changes in groundwater levels in the associated alluvium, because in most degraded rivers in southeastern Australia, the river has chewed out its bed and dropped, and hence groundwater levels around it have also dropped. So if you get geomorphic recovery occurring, the groundwater levels will also start to recover. As I've indicated in the early photos, that Wallenby Brook went through a process of, has been going through a process of geomorphic recovery. We believe, although I've not seen paired measurement to say what level groundwater levels have been recovering, but it does mean there's greater interchange between the river system and its alluvium, and that will also mean that the gaining and losing rivers will tend to have much greater interaction, and that will help guard things like water quality.
So just conscious of time, Fergus, we've only got another 3 minutes, so sure. I think we'll have to wind up questions there. I'm conscious there are a couple more at this end, but I might have to contact you directly. Thank you so much. That was, I think, an excellent example of science communication, complex issue, explained really clearly and showing what good science can do in terms of rehab options. The picture up on the screen really says so much. So, yeah, great job. Thanks very much. And a big... Did you want to say?
Yeah, just one more comment. The state feature classes, I'm working with Aaron Grimston, Richard Roger, and his group and their group to have all the feature classes ready for River Styles, ready for release, which will probably be in July. So keep your eyes open. You'll be if you request or need access to geomorphic information, the feature sets will be available. And we use it for both risk analysis. It can be used for regulation. It has been used in court for enforcement procedures. So it's a really valuable data set.
Yeah, incredibly valuable. So maybe we'll be bringing you back in 6 months' time for another lunch and learn. Yeah, that was a fantastic couple of presentations. Another great turnout. Big thank you to the knowledge coordination team. Really, another successful forum. So thanks very much, everybody.